Have you ever pondered on the building blocks of complex mathematical functions? Well, a key ingredient is what we call composite functions. A composite function, represented as f circled g, is a function resulting from the application of one function to the output of another. Think of it as a function within a function. If you have two functions, say f and g, with f mapping x to y and g mapping z to w, their composite function, f circled g, maps z to y. This is achieved by applying ge to an input z from its domain and then using the resulting output gz as the input for f, resulting in fgz. It's a bit like a two-step dance. First you take a step with g, and then you follow through with f. But there are some key properties to remember. Firstly, the order of composition matters. In other words, f circled g is not the same as g circled f, unless certain conditions are met, such as when f and g are inverses of each other. Secondly, the domain of the composite function must be compatible with the ranges of the individual functions. This means the input values for g need to fit within its domain, and the outputs from g, which become inputs for f, must fit within f's domain. Lastly, composite functions often sport a function notation with a circle represented as f circled g of x equals f of g of x. And why are composite functions so vital? Well, they're a foundational concept in various mathematical disciplines. In calculus, the chain rule, a cornerstone of differentiation and integration, leans heavily on understanding composite functions. In linear algebra, matrix multiplication can be viewed as a special case of function composition. In abstract algebra, the composition of functions is key in studying group theory, ring theory, and other algebraic structures. In physics and engineering, many models involve chaining multiple operations or transformations, which can be effectively represented using composite functions. And in computer science, function composition plays a critical role in functional programming paradigms and algorithm design. So, by understanding composite functions, mathematicians and scientists can model complex relationships, analyze systems, and develop new mathematical frameworks. In summary, a composite function is a function within a function, or the application of one function to the output of another. It's a vital tool in mathematics and science that helps us to model and understand complex relationships. Remember, order matters, domains must be compatible, and the notation is f circled g of x equals f of g of x. So the next time you find yourself grappling with a complex mathematical function, remember the two-step dance of composite functions. It might just make your mathematical journey a little bit easier.